All right, folks, good morning. Let's start. Okay, so today we'll look at, one of the attacks. This attack by environment variables when we are using setuid. Okay. All right. I hope all of you understood setuid concept. Okay, we'll revise it for a very short time because you will have to use this in your coding practice. Okay, or assignment that you'll get very soon. Okay, all right. So the contents of this I have taken from Van Liang Du's book. That's available. It's a nice book. It only talks of practical aspects of security. So it's quite nice, but requires a lot of concentration to read this. Okay. All right. So all the concepts also the author has presented through examples. So it's quite interesting, right? Because most of the other books are theoretical in nature, so we're trying to combine both concepts and and practical approach in this course. And please let me know if you get bored with one, because when we talk of practical aspects, okay, or it requires actual coding and knowledge of Linux. So at times it becomes heavy for those who have not done coding on C and Linux. Okay. All right. So these are the contents. We'll try to cover all. Okay. Some things I will leave it for you to read. So last class we have studied concept of setuid program. And when we have non-setuid program is ordinary program. So this program is ordinary program, normal program, may be owned by root user, okay, or it may be owned by root or super user, okay, it may be owned by anybody, okay. But when we execute, suppose when I am executing this as a user, or my process executing as a user, and my user ID is 1000, say for example, because when you create a user ID on Linux system, you get user ID number, right? It starts with generally 1000. So, and 0 to 1000 are that used by system for other processes that it creates. It provides those user IDs to those processes. So now user ID for me is 1000. I am ordinary user. I am using a program that is owned by the root. Okay. Now what happens is that, and I may want to read a file, okay, and wherein UGO bits, the user group others bit is 111 000 and 000. It means that before reading this file by the user which is I, user of this program, okay, which is ordinary program, okay, it will check, OS will check, what is, because I am the user. So this, with this program, the user ID is 1000, right? So it will check whether I am or this process is eligible to read this or not, right? And it will find out that I am in others category, okay, because I may not be, I am surely not owner, I am also not part of the group, okay, because group with every file, what are the members in the group, that's also specified. So I am not in the group, so I am part of others, and then it means that only root has permission to read and write, so I will not be allowed. Now this may cause problem by OS, all the because if user has to read something, okay, and system also may want user to get some information limited in a limited form, not everything, then what it can do is that it can create that logic of limited form, limited functionality in this program, limited what is functionality. Okay, and then this program has, you know, this bit set as 1. What do you call that? Set UID bit set as 1. So note that every program has under UGO model, okay, 9 bits plus 3 extra bits, right? So this is UGO bit. Okay, if that is so, then this become very special program. It means now the owner, the user process which is using this program, because you can use any program, right? The user ID remains the earlier one, but effective ID that is used for access control becomes that of a owner process, right? So now effective user ID for this program becomes 0, which is root. Right now, this program, when it accesses file, it is allowed because only root is allowed. Okay, you got the concept? Anyone with that has confusion? Okay, is it clear or not?
Yes, sir.
So
Yes, sir, it's clear.
yeah, so basically what's happening is that either you ask OS to do this special kind of works, or OS says that I'm delegating this work to one of my helper. Okay, and I will give limited functionality to that. I will not give all the powers of root, right? I will give limited power. That's allowed for this particular user or all sets of users. Okay, so that way a number of programs can be made that have limited functionalities, and in that this bit can be set, right? Set UID bit can be set. Now this causes security holes. That's the reason we are reading. And first thing is that you should also know, when you do coding, right, that is there any such thing when you are using a program, okay, a library function or any program, right, whether this bit is set or not, that you need to know. Okay, all right. Maybe this function is you don't know about this bit, then this, if this program that you are using, process that you are using, if that has holes, okay, or security vulnerabilities, right, that we have studied, and then some external entity can use, you know, super user IDs rights or roots right to access confidential resources. All right, so let's go ahead. So please go through it again if you are interested. And basically when the set UID base is set, okay, then owner of its owner, say root, becomes effective user ID, but it's applicable only for execution. At the time of execution it happens. All right, so set UID bit corresponds to the execution, okay, of what? Of the owner. Okay. So basically, limited way rights are given to user to use certain resources, but not full power of the root is given. So that's very interesting concept. And then yesterday we have seen this, right? Right, when we say change modes, chmod 4755 to a program, okay, the effectively we are changing this program into set UID program. Once we convert this set UID program, then anyone that uses this program, which is set UID program, which you convert into set UID program, anyone, it could be anybody that uses it, any process uses it, it could be any user ID. Then the And now since a set UID is owned by an owner, it could be anybody, and our example is corresponding to root, okay, with ID 0, then this process for the functionality that's here, okay, has root privileges. Okay, all right. So this is a concept. Now let's see how we can do attack. Okay. So in general, you think of this model that when you are trying to attack any program, this could be any program, the attack could be through what? Okay, attack could be through input. What is the example of input we have taken? We have done this. Okay, when you give malicious inputs, right? Now you can give malicious input because inputs are coming from outside. You can give malicious inputs. What examples we have studied, right? Where we give malicious inputs? Anyone? What did we study?
Shell code.
Pardon?
Shell code.
Again, come back.
Shell code.
Shell code, yeah, shell, fine. I mean, basically, we have, we have used in printf function. Okay. Format string vulnerabilities, right? I mean, in the printf function is specified whatever, right? Slash whatever, and then it effectively reads something else, right? So where input is given by you. Okay, so the input could be, or even in buffer overflow, you give input, right? Okay, external input or printf function, right? Format string, what we call is format string vulnerability. That we have studied both in detail, that inside printf function, it expects certain format specifier or format change specifier, right? And you give it in a way that this program cannot interpret, and then it looks at certain area based on that, right? So of sec. Okay, so these kind of vulnerabilities are about the input. What could be second one? Is because of environment. When you run a program in Linux, what is the environment that you expect? Yeah, anybody? Anyone? What is the environment, right? There are something that your program picks up from environment, or your program's behavior is based on the environment. Now you can always say, no, very simple things. For example, environment, you don't write your program considering RAM size. You don't write your program using something else, right? Cache size. Or something. These are also environment in some sense, right? But environment here is that something that is used, but you are not aware of that most of the time. Ideally, you should be aware of it, but most programs are not aware of that. So we'll look at that. Okay. Okay. So here is environment variables, which comes from environment. Okay, these are input variables. And third is system variable. Some system inputs you get from the system. Okay, now these are the attack surfaces. Okay, you can think of more also. But generally these are you can also say that something that's inside could also be a problem, right? But like in insider thread, etc., right? So there is a malicious program running inside, but let's assume that that's not the case. You know, whatever is running inside does not have any, you know, malicious code or whatever. This is just a program. Okay, so these are the attack surfaces. Not necessarily that these attack surfaces, you know, every program is vulnerable to that. Maybe some programs are vulnerable, but this is generally the way attacks can happen. Okay, considering yourself, let's look at analogy for yourself. Okay, you are here as a person. Okay, it's all the philosophy, but it can be applied. Okay, now what kind of attack surfaces you have? We have environment. You are living in a hostile environment. Okay, there's a problem, right? We have virus, for example. This is because of the environment. Okay, now environment may be malicious, and if you are not aware of the environment is malicious, then there is a problem. Okay, for example, you know that there's a very high probability of catching corona if you go to hospitals nowadays, right? Okay, or you go to a restaurant which is fully air conditioned, or you travel. Okay, now if you want to reduce the chances or reduce the chances of catching corona, then you avoid that, you know, until unless necessary. But you know, normal practice, you avoid even doctors nowadays, right? That going to hospital where there's a corona ward, very likely that one might get it, right? So environment can make problems for us. Okay, or if you're living in a kind of if somebody is not you, but somebody is living in, say, very a family. Okay, that's very, that has very different kind of environment, right? At home, right? I mean, everyone is cranky, or you know, one of the parents is drunkard, and you know, all kinds of things happen at home. Then the environment is not so pleasant. Okay, now if there is a person living, as a person is a nice person, then the person doesn't know that environment is malicious, then will get impacted. And it happens in almost every family that something or other member of the family is, you know, having some kind of behavior patterns, and not knowing that is a problem, because we get impacted because of that. Now if you know that there is a situation about the environment around, then you prepare yourself, and you know that this person is like that, or there will be certain behavior patterns, and I need not get impacted internally, right? So this environment. uh, okay, where are we? Okay, gone somewhere anyway. And then there are inputs, right? Okay, so you get inputs. For example, somebody abuses you. Okay, somebody abuses you, I mean, and then it could be anybody, your friend also, or your siblings or parents or anybody. Now you have two choices, right? Either get impacted or not get impacted. Okay, the ideal is that somebody is trying to make you angry, or abusing you, criticizing you, telling you about your you know, yourself something. Okay, and the person may not have any right to say, but you get impacted because of that, right? And then how do you protect them from any stimuli that is malicious coming to you? By knowing that the input is malicious, and then scanning it, or you know, scanning it in the sense that in case of computer, you can validate the input. But in your personal case, you must be aware of the input, right? What input is coming. The moment you are aware, then you can take protective action, not getting him. When if somebody is verbally abusing you, you protect yourself, right? Not by responding, just smiling and thinking something else, or being quiet, or moving away from there, and so on. If somebody is throwing a stone on you, then of course you have to protect yourself. But if you have shield, protect with a shield, otherwise run away, whatever, right? Okay. And similarly for system, right? The system in which you work, the whole country, for example, or institute, etc., or whatever is malicious, then of course you have to take care of yourself. Okay, so you can apply this model when you want to protect yourself. And even if you are writing a program, when you code, then you have to think that I am implicitly assuming there are environment variables or not. Now, if you're not aware of environment variables, then there can be some malicious activity through environment variable. This is what we are going to study today. For input variables, we have already studied buffer overflow, and when the input that you get that is trying to cause a damage in system, if right in the beginning of program has a logic to check the input, then large number of attacks can be avoided. When you write a program, for example, and then is and you use, for example, integer which can have negative values, while you think that it has to be always positive value, like age of a person can't be negative, right? And then you build the program based on that, but you take only while declaring, you declare integer, and then a user can input value and put -100, right? Then your program logic will go for toss. So while programming, you'll have to take care of it. Or even if you are using integer because of some reason, then sanitize the input. Input comes and you check whether it's in the range. All right. Okay. So as a programmer, this model you'll have to keep in mind and see that when I'm writing program, is my program secure enough? Only from these three aspects. All right. So now let's look at what environment variables are. Okay, so these are hidden inputs, which normally when we code, we are not aware of. Most of us are not aware of, but you have to become smart to become aware of it, right? So environment variables are a set of named values that can affect the way process behaves, although we don't know about it. Okay, a program doesn't know. As a programmer, you coded a program and you are not aware of this environment, but this impacts the behavior. Okay, these variables are set by users, can be set by users, not, but most of the time we are not aware, right? But can be set by users before running a program, and that are part of the environment in which program runs. For example, path. Okay, path is a variable, right? When you type path in terminal, okay, path, then it gives you the path. Path of what? It gives path of what? Okay. All right. So look at this way, right? So I am echoing here path, right? Okay. So basically, so it will tell me what the paths are. The paths is a variable. So when I use function echo or echo command, it prints a command nil argument. So you can see the list of directories, right? Like for example, I am seeing this. I am seeing this another one. So there is local /sbin, then bin, then user /sbin, and so on. So these are list of directories. Okay, so you look at how function path we are using in general, right? Now there is another way. See, in C, for example, when you declare a function, you do it in these two ways, right? Int main, and then there's no argument, and then you say argc and argv, right? These are the two we have even studied in when we had examples in OS class. But there is a third declaration also, which we are not which we can specify, but if you don't specify explicitly, then it's assumed implicitly, right? Which is this environment stores all environment variables. So we have here third argument, which specifies a envp. Okay, all right. Now here there's a small program that's written, that's available in the book, to print all environment variables. Okay, when I run this, okay, if you don't specify even this, even then it will work, should work, because an environment is anyway there. Okay, so now here you can see all the environment variables. What are these? It will tell you what is the shell I am using. It will tell about terminal. It will tell about whatever temp directory. It will tell about socks, present working directory, login name, and so on. There are many such things, right? These are the environment variables in your program. Then you use, right? Is there, whether you are aware of or not, aware of or not. So one example could be, for example, okay. Now the question is that where do you get these environment variables? Okay, when a child process forks, sorry, a parent process forks, and a child is created. Okay, you have you know fork process, right, from your OS course. Then the child takes all environment variables from the parent. Okay, it runs in the same environment. Okay, and now the other thing we have seen that, you know, we studied that, you know, running creating child, basically child copy has the same copy of the code and other you know, stack etc. as that of parent. Okay, state is same when child starts, excepting for, you know, ID would be different, but everything is same. So it's not very useful all the time. Okay, but when we put in the child you know, different code, and that we do using excv system call, then it behaves differently. Now when we are doing that, then what are the environment variables? Then in that case we can define, although we have not done that kind of coding, right? Then we can define environmental variables, you know, like this. You have this excv call and then two parameters that we specify, and then here it is environment variables. Okay, any question? No? Are you able to understand?
Yes, sir.
Okay, all right, let's go ahead. Okay, so now question is that when you write a program, when inputs are normal, you know, when you write a program, you remember to do validation on inputs, because inputs are coming, you know, and of course, man, not many programmers are careful, you know, but you being a good programmer will always check what values the input can take and so on, right? So these are however, there are some implicit inputs like environment variables that programmers often forget to validate. Okay, and then some programs use these environment variables internally. They always use it. Shell program, for example, use it internally. When you say in shell program, you say, you know, and there is some shell is open, and then you execute a file. Okay, you say, for example, cat, or do something. Okay, now where is this cat? You don't specify, cat, when you give cat a file name, cat is also a program, right? So where is it but? Okay, you don't specify that. Now the knowledge about where this, in which directory this cat program is kept comes from the path. Okay, the path gives a list of directories, so it will search directories in particular order, and as soon as it gets the cat, it executes that. Okay, all right. Now environment variables can be controlled by user, of course, yes. And user can indirectly affect the behavior of program by changing values of some environment variables. And this is where set UID becomes important. Okay, you'll have to check whether even set UID bit is set or not. When using a program or you are writing a program and a user can use that program, and you'll have to check whether set UID bit for that is set or not, because set UID bit comes under environment category. Okay, let's look at an example. Okay, this point we know the shell program behavior is affected by many environment variable, and most common is path variable. When shell program runs a command, the absolute path is not provided, right? We don't provide absolute path, right? It uses path variable to locate the command. Because I mean, we have seen these are when we ran the shell. Wow. Okay. Not here. I think somewhere earlier. Well, anyway, when you simply run path, then it will give you a list of paths. Okay. Okay. Anyway. Okay. All right. So now let's consider the following code. Okay, this code is as follows, right? Is one val.c, and then you have here system, and then you want to run calendar, right? CAL stands for calendar. Okay. Now you know what is the system cal command. So what is the system command? Anyone? When I run this, and inside I can have anything. I instead of cal I can have any other thing, ls minus l or whatever. I could have this also, right? So system is basically a function. Okay, and then when you give whatever inside here like cal, this thing works as a shell. Okay, it's same as running shell on terminal and giving command cal. All right. Okay, so system doesn't work directly here. In this case, it invokes /bin./shell program and use sh program to run calc. Okay, so when you run the system, immediately it runs this one /bin shell program, and then you run cal program. So now how does this bin slash will find cal program, where the cal program is there? It will search all directories in the path. Now, ideally, we are supposed to provide that it's a part of the bin directory, right? But we are not done that. Well, most of us don't do that. Okay, so it will look at the path. So path contains folder 1, folder 2, etc., right? Okay. Okay, if this is set UID program, then the attacker can attack path environment variable to force privileged program to run another program instead of calendar program. How does it run? So instead of calendar program, we want to run something else. How can we do that? Okay. See, calendar program has name cal.c, right? Okay, or cal.exe or whatever. If it's a exe file, then obviously it will be exe file, it won't have source code. So what we can do is that instead of that, we can force program this to run cal dot this malicious code. Okay, so in that we define cal.c as follows. We can define it, include whatever, and then you define system /bin/bash -p. Okay, instead of cal, whatever code for cal, okay, is there. So that cal definition is also there in one of the directories. Now what we do is that we create a function like this, cal.c, and put it in the path, one of the directories in the path. Okay, all right. So now what we do is that, okay, when ordinarily you run a program, okay, we are running now world.c. Okay, so here is world.c where we are running this one, right? So it will print us a calendar. Okay, now to this program, we first compile and create executable. Okay, and then ownership of that program we give to root. Okay, of course it will ask for password, etc. Okay, and then we change this program, vulnerable program, to privileged program by setting set UID bit. Okay, now you run this. What will happen? It will print the normal calendar. Okay, because I mean it has done it tries to find out where cal is, because cal is part of this code, and it finds out in the directory, one of the directory, it executes that. So all this is whatever we have done does not have any impact. However, if you put your code in a directory which is searched before this malicious code, okay, cal, if you put in a directory which comes this code which is searched before the normal cal program, then you are done. Okay, this is what exactly we are doing here. Okay, we are changing the path. So this path is now is dot whatever. So basically now I'm okay. Now when I can echo path and see what the path is according to my thinking or not. All right. And when we run this program, I note that here we are running it dot/virl. Now we are running as virl. Okay. Now the default shell comes up with root privileges. Because root privileges comes because because this is set UID bit is set here. All right. Okay, got it. So this way we can do manipulation. Any question? Run this code. I ran this code and then got the actual understanding. Is there in the book. All right, so let's move ahead, right? So we have seen that environment variables, they are implicit if you're not setting it. Okay, you have option of setting the environment. If you're not setting it, these are implicit, and you have to be careful about it, right? Because through these environment variables, attack can happen. All right. Now, second attack surface is through user inputs, which we have already seen in case of buffer overflow and format string vulnerabilities, right? And now these along with set UID bit can be quite dangerous. Okay, so we are not going to study that. And then there can be system inputs that are controlled by user, like race condition, etc. Right? Okay, so I am not again going to get into details. The book has about 10 pages on this, so if you are interested, please go through it. All right. So I just want to tell you that these are the 3 ways in which attack can happen, and start thinking about it. Okay, one simple question that you start thinking about it, because the objective of this course is not to put a lot of information into your mind, but open your mind to think, because I am doing same thing to myself, right? So I am not security expert, but it lets me think. Okay, so one question that you can answer or start thinking about is, yesterday we discussed a program wherein your friend is working on a laptop and goes to loo, and you have 1 minute and you do something. You do set UID bit and copy the program to some file, temp file, and do all that. Now your friend has given you a mobile, okay, and it's open in the sense that it does not have security. You don't have, the screen is not locked. Okay, what can you do in say 5 minutes such that your phone will have access to whatever happening inside? You can see all SMSs or emails, etc. So can you do something about it? What action you need to do? I mean, you need to type here something. That's the only thing that you have. Okay, you understand the problem? Your good friend, your intimate partner, gives you a phone on trust, or the screen lock, and you apply that, phone is open, you have 5 minutes, you do something, and after that your partner's phone is visible from your phone. What all you can do? Think about it, right? Think about it. Now you have done OS course. Android is based on Linux, so you know all internal structure of Linux also, in bits and pieces, of course not everything. So think about it, how can you manipulate? Okay, all right, let's spend another 10 minutes and then we'll close. Okay, so now attacks can happen also via dynamic linking. Okay, do you know about dynamic linking? Have you ever read this or come across this? Anyone? Can anybody tell me? Gunjan, Micah?
Yes, sir.
Have you heard of this term called dynamic linking?
No, sir.
Okay, that's fine. That's fine, because you have not done systems programming course. It used to be, but possibly when you do compilers, you will come across this term. Okay, the process of you write source code, right, and then you simply compile and execute it. There's a lot of steps hidden in between, right? So when you this of course the diagram we have discussed in computer architecture course. Okay, so we have hello.c. We pre-process it like you have all macros, etc. that you have written. You defined a variable or sorry, constant like before program. Okay, hash define or whatever. It's all gets processed with this one. Okay, then you have source code still is in C. Okay, then you compile it, then it becomes internally it becomes first assembly language program. Okay, and then you are in your program source code, you are using various functions, and that comes from outside, like printf function, or it could be any other function or any library function, right? Say you are doing square root or whatever, and then some mathematical function which you don't have in C. Okay, so now all these get linked, and finally you have executable code available. That's what we do. Okay, now do you think that here the output will have both your program, which is hello.c, hello corresponding to hello.c, it's a machine version. Okay, and then printf is functions machine version also, right? It will get associated. Okay, now assume that you have multiple such programs or subprograms, and they are using printf. Okay, now all of them will get printf corresponding function clubbed. Okay, so what happens is that in linking, whatever library functions you are using, ultimately object code of that will be available in the code that's in execution. Okay, otherwise you cannot. Now this can be done in multiple ways, right? Okay, so here is the example. First we'll look at a simple example that corresponds to static linking, then we'll talk about dynamic linking. Then I will discuss for a brief what kind of problems it can cause. So this is a main program. This is a a function swap.c, and so what happens is that, okay, so when we do static linking, okay, both of these functions, which is an object form. Remember in the last course I have asked you to read ELF format. Now ELF format is a common format for object code, right? And executable also, right? So now these two, which are usually in the form of ELF file, anyway, I mean, okay, they get linked because in a source this could be written by somebody else, this is written by you. Okay, and then after these processes you have object code, and this object code gets linked because they need to be combined. Okay, and then you have output at the end, which is executable. So which is fully linked executable object file, which contains code and data for all functions defined in main.c and swap.c, right? And when you put this is a file, and when you put this in RAM, then it becomes process. And who puts this in RAM? Something called loader. Okay, remember this functionality, right? Okay, so program heavily use printf function, for example, and linker combines program code and printf function. This was an example, right? Okay, if there is a printf function in multiple places, multiple programs which are running in parallel, then there are multiple copies. That's one disadvantage of static linking. Now linkers are used because of modularity, because you are writing, suppose there is no linker and your program is just set 10 lines program, and out of which you are reading 5 or 6 functions. Okay, your program can be very small, it can just use those functions, and these functions will have some code that will come into play when the final code is prepared. Okay, now this function is used by everyone. Okay, the library functions, so everyone need not write those functions like square root or multiply or matrix multiply or something like that. Not everyone needs to write, so you can use standard functions available, and so it becomes modular. Okay. Okay, and then secondly, compilation. You don't need to compile these these function library functions. These are already available in compiled form. Okay, you just need to link it. So that's advantage, right? Because that has been compiled some time back and available, and then you compile and object forms are available. Okay, and of course you have so basically time to compile etc reduces. At the same time, space reduces because libraries are available, and libraries can be used by anybody, right? Otherwise, every user will have those will have to write those. Okay, so common functions can be agreed. So your program, for example, is using it's a multiple root functions in that are using this, then there is no need for multiple copies of those functions. So only single function will do. So we have advantage in terms of time and space. Okay, it does two main things: symbol resolution, because both code may have similar kind of symbols, right, that you will study in your compiler course. And then relocation. Okay, because there can be relative jumps and so on, right, branching instructions and so on. Now it has to be correct. Okay, because now combined code is one, so these need to be corrected. Okay, these are two functions. Of course, you study in compiler course. Okay, so basically you get relocatable object files, then executable object files, and shared object files. There are three kinds of files. Okay. Okay, I will skip this, and generally we have studied this in ELF file format, right? This is the ELF file format where we can have any of these, right? We can have O file, executable file, or SO files. Okay, there's a common format defined for that. Okay, so we'll not go into it. So now we have three relocatable objects, basically three programs that relocatable objects are of this form: system code and data, and then we have two here, main and swap, and then we combine these relocatable objects, okay, and create this kind of executable file. So basically we have text portion and data portion as part of ELF file. For main.o, similarly for swap.o, we combine this and we get then one object file, right? Okay, and then when we load this object file into main memory, we get the structure that we have studied, right? We have stack, we have runtime heap, and then we have memory mapped region for shared library that we have not studied. Okay, so now what happens is that what we have studied is static linking. Now executable file at this point has all library functions also available, okay, that have been used. But there is another way is called shared libraries or dynamic linking, okay, where only at the runtime, if your program uses a shared library, only at the runtime the library comes into play. That function comes into play. That function is brought in by loader and executed. That's called dynamic linking. It means the linking is happening or the function is brought in only at the runtime. The function is brought in from library only at the runtime when there is a call to library function. Okay, now this reduces a lot of problem. Okay, all right, so please go through it. Okay, so there's a process, we have executable, okay, then we have loader, then we have dynamic linking, and when the at runtime, when this is over, then you start execution. Okay, all right, so where is the problem in dynamic linking then? What can go wrong? Okay, all right. Okay, linker is usually not out of your control. Now, very simple thing is that linker has to find the functions you have called in the main program. Okay, and so it has to search certain libraries or certain places, right? Is equivalent to path. Okay, now if a malicious program can put something out there, okay, then those malicious code will be linked. So dynamically linking uses environment variables which become part of attack surface. All right, so there's a concept. All right, so go through it and learn about static and dynamic linking, and then also find out what kind of attacks can happen because of dynamic linking. So I have not included the dynamic link attack excepting for the very small thing we have discussed, because dynamic linking is happening in the background which you are not aware of, and this is where attacks can happen. So just read more about it. All right, okay, thank you. Any question? All right then.